My name is Yaman Sirajuddin, and today I'll be presenting assignment 1 for the Advanced Machine Learning course. So let's get started. This first line of code installs the required libraries for this notebook to work, which are Pandas, Scikit-learn, and Joblib. Okay, so standard libraries. Okay, and then we're loading the data, we're importing Pandas, and we're creating a seed variable which will be used throughout the notebook by the random states. Okay, this ensures that we have reproducible results if we rerun the notebook again. Okay, and then we're just reading the CSV file from the banknote authentication CSV file, and then I'm displaying the head, which are the first 5 rows of the data frame, just to make sure that the data is loaded properly. Okay, the data splitting. Okay, so to split the data into a train, validate, test slices, so 70% train, 20% validation, 10% test. I created this little function which does this for me. Okay, so I can use it later on in following assignments. First, we split the data into the x and y components. Okay, in this case the x component is like all the columns without the class, and then the y component is the class column. Okay, so the train validate test split, it just basically calls the train test split twice. So once to separate the training data from the total data, and then another time to separate the test or the validation data from the test data. Okay, and we get the final results here. Now moving on to the model. So, and there is an important assumption that I made, which basically states that the class of a row determines whether the currency is counterfeit or authentic. So 0 means that the currency is authentic. Okay, so it is not counterfeit, while 1 means that the currency is counterfeit. It doesn't state in the description, so we weren't given a very precise description of the data that we have. So I made this assumption. It might result in incorrect so basically, yeah, this assumption the whole model depends on this assumption. Okay, if it's not correct, so if it's the other way around, we'd have to switch things up a bit. Okay, now we have the model. So we start with the linear regression classifier. Okay, so we're doing the imports, and then they've created this report function which basically outputs the validation. So it outputs these scores and then draws the confusion matrix. Okay, so it uses the scikit-learn functions to determine the scores. Okay, the average is binary because we have two labels which are 0 and 1, and we're defining 0 division as 0 just to be safe. Okay, we're determining these scores, and then we're printing them out with some Python formatting. Then we're getting the labels and drawing the confusion matrix, so there is nothing special here. Then we're creating a pipeline, so this pipeline is basically combining multiple parts to form a single model. Now in this pipeline we have two components. We have a scaler and we have a rigid classifier. Okay, so the scaler, in this case I've decided to use a standard scaler, okay, which uses a mean and the standard deviation. So what this does is basically standardize the input data and the output data, obviously, in order to how should I say it? So in order to soften the effects of the value of input parameters that have high values. Okay, so this is basically regularization, okay, but for the input parameters, so for the axis of the function. Okay, regularization works on the weights, this works on the parameters. And then we have the rigid classifier, which is basically a linear regression model, but instead of spitting out a real value, it spits out a classification. So it basically does the threshold comparison internally. Okay, so we don't have to do that. Next we have the linear parameter grid, which defines the set of alphas that we want to test. So the alphas here represent the level of regularization. The lower the alpha, the lower the regularization, and the higher the alpha, the higher the regularization. Then here we're defining a stratified k-fold with 5 splits, okay, and a grid search CV. The job of these two is basically to determine the best alpha, okay. And to do so, we're using 5 splits. So basically, we're splitting each training iteration, the data in each training iteration, into five slices that have approximately the same size. So 5 subsets that have approximately the same size, and then we're training the model on 4 of them, and then validating or testing it on the 5th. Okay, so this is what's basically happening. We're passing the model, the parameter grid, and then the scoring function that I've decided to use is the recall, and I'll get to that later on. Okay, so we're just training the grid, and then we're taking the best model, and we're reporting our findings. Okay, so these are the results. So as you can see, we have very high scores. Okay, and the best alpha is 0.01, so it's 1e minus 3, I think, or it's 1e minus 2, like, I don't have an idea. I'm not gonna confuse the scientific notation. Then moving on to the logistic regression classifier, we have approximately the same thing, so the same pipeline, but this time, instead of using a rigid classifier, we're using logistic regression with a penalty of L2. So the rigid classifier has a penalty of L2, however, it's defined implicitly. Okay, so you don't have to state it. Here in the logistic regression, you have to obviously state it, as I think the default is L1 if I'm not mistaken, and we're specifying the number of iterations. Okay, the hyperparameters in this case are C, which is the inverse of alpha. So basically, if C is low, okay, we have a high regularization, and if C is high, we have a low regularization. Okay, and then we have the solver. So this one is suitable for small data sets. This one is suitable for binary data sets that have like 2 labels. So in our case, so it's the same as our case. And then we have the Sega, which is suitable for large data sets. The solver is considered the hyperparameter, and thus we're giving it to the grid search CV. Here we're obviously focusing on the recall. Okay, so the number of jobs is -1, so just basically telling the code to use whatever resources it has, so you can parallelize it, make it more efficient, just fitting and then reporting. So in this case, we have like it's a very similar score. So the best solver is LBFGS, and then the best C is 1. Okay, however, notice that the recall in this case is a bit lower. So why am I focusing on the recall? So basically, we're assuming that a 0 means authentic, a 1 means counterfeit. Okay, so if we have a false negative, okay, so we're basically detecting a currency that is fake as authentic, we're taking that banknote, and we're basically losing its entire value. So basically, if a customer gives us a counterfeit note, we're losing the product, and we're losing the change that we're giving to the customer. So we're basically just losing the amount of the banknote. Okay, so it's very critical that we don't have any false negatives. Okay, so we don't predict any counterfeit banknote as legit. Okay, we can basically, like, it doesn't matter that much if we predict a false positive. So basically, if we detect a real currency as counterfeit, I mean, at the end of the day, the worst that could happen is that we lose a customer, maybe. Okay, so like we don't lose anything, but we don't gain anything at the same time. So it's very crucial that we don't have any false negatives. Okay, and that's why I chose the linear regression model, because it has no false negatives. Okay, and I've tested it on multiple seeds. It yields the same result, so no false negatives. Okay, now to get the learning curve, we're basically taking the best model, okay, which is a linear model in this case, and we're creating a learning curve. And here, by the way, we're not using the best model, so we're actually retraining the best. We're retraining a model that is based on the best model. Okay, in order to get the training curve. Okay, we're focusing on the recall, and then here we are telling the linear learning curve to start from 10% of the data and go all the way to 100% of the data, which is the training and the X train, Y train, in increments of 10. Okay, so it's 10%, 20%, 30%, etc. until we reach 100%. Okay, and we're using the 5 cross validation, this same as above. Okay, and here we're just plotting the curve. So we can notice that this curve is so basically the blue curve is covered by the orange curve up here. We can notice that the curves are almost identical. Okay, and like the dip here is a negligible amount, so it's not really a dip. That means that our model is very efficient for this task. Okay, it's not underfit, it's not overfit, it's just right. Okay, so it works pretty good on this task. Okay, so here we're explaining the logic behind our choice, which is what I said. Basically, the number of recalls is what we care about the most. Okay, and here we're just saving the model using joblib, so we're dumping the best model. So this step basically dumps the best model, like it dumps the entire pipeline. Okay, so we don't have to create a standardizer again and just feed it and then feed the data that comes out of the standardizer and give it to the model. Like everything just sticks together as a single unit, and it is saved as a single unit, and it is loaded back as a single unit. Here we're loading the best model. Then you were using it to you were using here is the test data. So we're predicting and using the decision function. So basically the decision function, what it does is basically it returns the real value. Okay, so in our case, in the linear model, we're returning so a very positive value, a very negative value, okay, or something that is little negative, little positive. So it's something close to zero. Okay, and we're just reporting them. We don't have a grid CV here, and we get the following results. Okay, so it's very similar to what we want. Okay, so this makes us very confident with the model. Okay, so now what I'm gonna do is, so I've ran this using the seed 42. I'm just gonna like pick a random seed, which is like basically, let's say 1007. Okay, I'm just gonna run everything. Okay, starting from this cell. Okay, so run, and I'm using the machine learning Azure Studio in order to, like, I could compute this on my laptop. However, for future assignments, as the models get more complex, we need GPUs. Okay, so this would come in very handy. Okay, so this will be very much needed. Okay, so now we're retraining the models. We have 0. In this case, we have higher false positives. Okay, and here we have, in this case, we also have a 0. Okay, which is very weird. And now we have the training data. So the training data this dip, like it's over dramatized. Okay, here, like this is just 0.9998, so it's very small dip. Okay, so here we have a 0 and a 1. I'm gonna do a second one, so here we can refresh, like, to see the actual data. I'm gonna do a second one. Okay, so let's do like something like this. Okay, and then like run the cell and everything below it, just to make sure that everything is working as intended. Okay, yeah, this video is a bit long, so we have the 0 here, and it's also 0. Like, this is very strange. Okay, this is unlucky. Like, I've tested this with like 2 different seeds before this, and I've had like very high results. Okay, so now we see a more significant dip, but nothing over dramatic. I mean, it's still very unremarkable. Okay, so we have this value. I'm just gonna do one more run to be safe. Okay, I'm just gonna go with 45. Okay, and then run this cell and all below. And we have a 0 here. We have a 0 here. Okay, so this is perfect. Yeah, this is it. Hope you enjoyed this video, and thank you for watching. Bye.